Good evening, everyone. Today we are starting a new chapter. The name of the chapter is Electricity. Now, this is again one of the most important chapters for class 10 students, and in this chapter, we will discuss the various concepts related to electricity. Okay, so let us get started. First of all, we will try to understand what exactly is an electric current and circuit. So let us try to define our electric current. Basically, electric current can be defined as the flow of electric charges through a conductor. The conductor, for example, can be a metallic wire. So basically, we can define electric current as the flow of electric charges through a conductor. Now, for this, an example of a torch is given. In a torch, the cells or a battery, when placed in proper order, provide electric current through the bulb to glow. Okay? A continuous and closed path of an electric current is called an electric circuit. If the circuit is broken or if the switch is turned off, the current stops because the flow of current gets disrupted and the current stops. So electric current is measured. How is electric current measured? It is measured as the amount of charge flowing through a particular area in unit time. So it is the rate of flow of electric charge. In very simple terms, we can say that electric current is the rate of flow of electric charge. So we have a switch. When we switch on, the bulb glows, which signifies the flow of electric current through the metal spring, and because of these two cells, the batteries. Okay, this is the schematic diagram of an electric circuit. We have a cell, we have a flow of electric current, the electric bulb lights up, and there is an ammeter. Ammeter is a device that is used to measure the current reading. Ammeter will give you a reading, that is the reading of the current flowing through the circuit, and there is a plug key. So electric current is measured as the amount of charge flowing through a particular area in unit time. So it is the rate of flow of electric charges. Okay. So in the circuit of metallic wire, electrons will constitute the flow of charge. Now charges are made up of two types, either positive or negative. So electrons, the negative charge, constitute the flow of charge. Electrons were unknown during the discovery of electricity. So electric current was considered as the flow of positive charge, and the direction of flow was taken as the direction of electric current. But what happened conventionally in an electric circuit, direction of the electric current is taken as opposite to the direction of flow of electrons. Okay, so wherever the electron flow is happening, the direction of the current flow is opposite. Electron flow is towards the blue side, left, right side. Conventional current is towards the left side. Okay, that's it. Electric current flows from positive terminal of the cell to the negative terminal. Okay, now let's move ahead and see that who discovered current, or the electric current SI unit is ampere. So who was Ampere? Ampere was a scientist, André Marie Ampere. So his name was André Marie Ampere. He was in France, 1775 to 1836. So the SI unit of electric current is ampere, and it is named after this scientist, André Marie Ampere. Okay, so now this is the schematic diagram of a electric circuit. This is the electric bulb. We have a ammeter here. This is the plug key, and this is the cell. Okay, so consider a net charge Q flowing across a current section, consider a net charge Q that flows across a cross section of a conductor in time t. This is the time t. Q is the net charge that is flowing across a cross section of conductor in time t, and then the current I through the cross section is I is equal to Q by T. So the current can be mathematically measured as I is equal to Q by T, where Q is the net charge flowing, and T is the time in seconds. Okay, so or same formula can be written as Q is equal to IT, where I is the current and T is the time in seconds. So SI unit of electric charge is coulomb. Same way, the SI unit of electric charge that is obtained is coulomb. It is equivalent to the charge contained in 6 into 10 to the power 18 electrons. So an electron has a negative charge of 1.6 into 10 to the power minus 19. Okay. And as I said, the SI unit of current is ampere, named after the scientist Andermatt Ampere. Okay, let's move ahead. Now, 1 ampere represents, this question can be asked, they ask, define 1 ampere. What does 1 ampere represent? So you can say 1 ampere represents the flow of 1 coulomb of charge per second. 1 ampere is equal to 1 coulomb of charge per second. Small quantities of current are expressed in milliampere. So 1 milliampere is 10 to the power minus 3 ampere, or in microampere. 1 microampere is 10 to the power minus 6 ampere. So what is an ammeter? An ammeter is an instrument to measure electric current in a circuit. Okay. Ammeter is an instrument to measure electric current in a circuit. It is always connected in series in a circuit. So this is something important. An ammeter is always connected in series in a, it is always connected in series in a electric circuit. Let us move forward and try to apply the formula that we learned in one numerical. A question is given. A question may be given like this, that there is a current of 0.5 ampere. So I is 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. First thing we do is we convert the minutes to seconds. So time T is 10 minutes is equal to 600 seconds. And what we have to find the amount of electric charge that flows through the circuit. So we know I is equal to Q by T. We are asked to find Q. So Q is equal to IT. We are applying this formula. Q is equal to IT. I is 0.5 ampere. Time is 600 seconds. So our charge Q is 300 coulomb. Very straightforward and easy question. So flow of charges inside a wire. Inside a solid conductor, atoms are packed together, but electrons can easily travel through it, almost as if they are in vacuum. So when an electric current, or when a current flows through a conductor, the electrons move with an average drift speed. However, an electric bulb lights up as soon as the switch is turned on. It is not due to the movement of an electron from one terminal to other. It is terminal through the bulb. Okay, there is nothing complicated in this. There is a copper wire. It has some negative charge, it has some positive charge, and the electrons are flowing through it. So flow of charges of current happens inside a wire. What is important here is to understand this numerical question, that Q is equal to IT or I is equal to Q by T. These are some formulas which can be used to measure any of these three dimensions by using the formula. Let's move ahead. Electric charges do not flow in a metallic conductor by themselves. Okay, here gravity has no role. See, wherever there is a high potential energy and to low potential energy, the flow of electric charge will be from high potential energy to low potential energy. There is always a potential difference created, because of which the current flows. So what will be the flow of current? Current always flows from high potential energy to low potential energy. Electrons only move if there is a difference of electric pressure in conductor, and that difference is called the potential difference. The chemical action within a cell battery can generate the potential difference across the terminals of the cell even when there is no current. When the cell is connected to a conducting circuit, when the cell is connected to a conducting circuit, the potential differences sets the charges in motion and produces an electric current. To maintain this current, cell has to expend chemical energy stored in it. Okay. Now let's move ahead. Electric potential difference between 2 points in an electric circuit is the work done to move a unit charge from one point to the other. This is a definition. Potential difference V between 2 points is work done divided by charge Q, and it can be explained that electric potential difference between 2 points in an electric circuit can be explained in simple words as the work done to move a unit charge from one point to the other. So potential difference V between 2 points is work done W divided by charge Q, or V is equal to W by Q, or W is equal to V into Q. So SI unit of potential difference is volt. V, this is again named after a famous scientist, Alessandro Volta, and he was from Italy, and this was his life, 1745 to 1827. So this scientist Alessandro Volta is famous for discovering the potential difference concept, and that's why the SI unit of potential difference is volt, V, which is named after Alessandro Volta, the famous scientist. High potential energy to low potential energy, the flow of current. Okay, let's move ahead. 1 volt. Now if they ask you the definition, define 1 volt, how can we define 1 volt? So 1 volt, what students have to write if it is asked what is the definition of 1 volt, define 1 volt. So how will the students write? 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move 1 coulomb charge from one point to another. So 1 volt is equal to 1 joule by 1 coulomb, or 1 volt is 1 joule by coulomb inverse. What is voltmeter? Voltmeter is again an instrument to measure potential difference. It is always connected in parallel across points between which the potential difference is to be measured. So ammeter is always connected in series and voltmeter is always connected in parallel. Okay, so voltmeter is an instrument to measure potential difference and it is always connected in parallel. Now we see one numerical, how much work is done in moving a charge of 2 coulomb across 2 points having potential difference 12 volt. So amount of charge given is Q is equal to 2 coulomb and potential difference V is 12 volt. So amount of work done is W is equal to V into Q, that is 24 joules. Joules is the unit of the amount of work done. Now we see some conventional symbols of some commonly used components in the circuit diagrams. Like an electric cell is shown by this symbol. A battery or combination of cell is shown by this symbol. Plug key or switch which is open is shown as this symbol. Plug key or switch that is closed is shown as this symbol. Wire joint is shown like this. Wires crossing without joining is shown like this. Electric bulb is shown by this symbol. A resistor, electric bulb is shown by this symbol. A resistor or resistance R is shown by this symbol. Okay. Variable resistance or rheostat is shown by this symbol. An ammeter is shown by this symbol. A will be written and voltmeter V will be written. Okay. Now what we can do is see Ohm's law is a law that was given by a scientist called as Ohm. So he had defined something called as a resistance. He had given us a new concept of a term called as a resistance. So Ohm is famous for that, and students can expect a question coming in board exam related to our Ohm's law. 100% I can assure you that Ohm's law question will be asked in the board exams, directly or indirectly. The question will be like, define Ohm's law. What is Ohm's law? 100% this question is coming in exam. Mathematically represent Ohm's law. So since Ohm's law is such an important concept, we will study this in the next video of ours for this series. For the first part, let us stop till here. Thank you everyone.